As another example, think of the function f of x equals 1 divided by x. Now, on the one hand, you could just blindly try applying the power rule, since 1 divided by x is the same as writing x to the negative 1. That would involve letting the negative 1 hop down in front, leaving behind one less than itself, which is negative 2. But let's have some fun, and see if we can reason about this geometrically, rather than just plugging it through some formula. The value 1 over x is asking, what number multiplied by x equals 1? So here's how I'd like to visualize it. Imagine a little rectangular puddle of water sitting in 2 dimensions, whose area is 1. And let's say that its width is x, which means that the height has to be 1 over x, since the total area of it is 1. So if x was stretched out to 2, then that height is forced down to 1/2. And if you increased x up to 3, then the other side has to be squished down to 1/3. This is a nice way to think about the graph of 1 over x, by the way. If you think of this width x of the puddle as being in the xy plane, then that corresponding output, 1 divided by x, the height of the graph above that point, is whatever the height of your puddle has to be to maintain an area of 1. So with this visual in mind, for the derivative, imagine nudging up that value of x by some tiny amount,